Hello everyone, I'm Asgataj, and in today's DSP lab experiment we'll be knowing how to use graphical user interface in MATLAB. Uh, in this we'll be performing the DTFT, and also we will calculate the main lobe width, transition bandwidth, stop band attenuation, side lobe and main lobe using graphical user interface in MATLAB. First let me show you the demo. In this we use the command GUIDE, which is graphical user interface development environment. When we run the command, it will show us this window. This window is created by us. It has two type of contexts. First is the dynamic context, and the next is static context. Static contexts are like length, choose window, main loop width, transition bandwidth, etc. These have a constant value and which cannot be changed. And some of the dynamic contexts are the text in which we enter the length and the choose window remaining. These are dynamic tests which can be varied from experiment to experiment. So let's take a run and have a look at it. As you can see, we can set the length of the current window we will be using. For this we'll be setting 25. So let's choose the window be rectangle. Upon running, as you can see, this is our rectangular signal pulse which we'll be using for the spectra of the required signal can be seen in this. The main lobe width is 0.25, transition bit width 0, stop band attenuation is 30.482, side lobe width is 33.9, and main lobe width is 64.3775. Let me show you the remaining choose window waveforms. For the triangular window, the waveform looks like this and spectra looks like this. For the Hanning window, and for the Blackman and Hamming window are very close to each other, except the fact that the zero convergence is faster for the Blackman. Now let me show you the code for this. Yes, the main lobe width, transition bandwidth, stop bandwidth, and side lobe and main lobe are calculated as follows. The main lobe width, pass band, side band attenuation, side lobe and main lobe. These are calculated from this calculate.m function. And the spectra calculation. MATLAB actually has a FFT direct calculation function, but we'll be using our custom calculation function for this. The function is defined as follows. So upon implementing on this, we'll get the required function and our required spectra. This is done using graphical user interface in MATLAB. Thank you.